Good morning, ladies and gentlemen, here in Santa Clara, California. We're at the Convention Center. We're up to day 3 now of Cloud Expo Silicon Valley. We have, therefore, our day 3 keynote next. Abiquo it is. Pete Malcolm it is, CEO. You're hearing an awful lot about Abiquo, I know, during the sessions, because I've noticed a lot of other players referring to Pete's company. So they must be doing something right. Let's find out what it is, and let's find out more about the enterprise cloud, which tends to be the theme of today. It's going to be enterprise, it's going to be business value for almost all of the 12 hours, certainly in this room. So let's give it up for Pete Malcolm, CEO of Abiquo.
Good morning. Anybody got hangovers from the party last night, or are we all okay? I'll try not to speak too loud. About 30 people asked me yesterday if I'd show that video we showed yesterday again, just describing what we do. So let's run that first, and then we'll talk about business policy.
Virtualization. Great, isn't it? We can move things around if the hardware fails or needs upgrading, or if we need more power. And we can move workloads around to more efficiently use the hardware we already have and stop us buying more hardware we don't really need. Yep, it's pretty awesome. Yeah, except for all the ways that it isn't. See, all this moving around does make it kind of hard to track where everything is. And working out just where to put everything to get the best utilization is actually pretty difficult, especially if you have to do it over and over every day. And what about governance, security, and compliance issues? Even so-called easy deployment is still a big headache for the overstretched infrastructure team. And of course, these problems aren't getting any smaller. But hey, why worry? Cloud computing is going to fix all this, right? What if the cloud could solve the problems of virtualization? If you could fully empower your users to manage their own environments without any risk to your infrastructure, freeing your IT team to focus on delivering the most cost-effective resources at the required service levels, and have it all automatically operate according to your organization's business policies. What if you could make virtualization and the cloud work the way you need them to? Well, they can. At Abiquo, we've created a solution that fixes all the old virtualization issues and delivers the cloud just the way you need it. Abiquo provides each organizational group with total control of its own virtual enterprise, where they can configure and deploy resources any way they want to, in seconds, and without any risk to the infrastructure or anyone else's virtual enterprise. Abiquo supports all 6 major hypervisors and ends vendor lock-in by providing drag-and-drop conversion of virtual machines between any of them. It lets your IT team manage infrastructure across the globe, whether it's equipment you own or services you buy in to provide elasticity, all through a single pane of glass. Abiquo lets you control resource consumption while providing drill-down accounting for billing and chargeback. Real-time displays and statistics keep you informed and make capacity planning and efficient demand-based elasticity a reality. And Abiquo's highly sophisticated business policy ensures governance, security, and compliance requirements, as well as your business goals, are consistently and automatically enforced every time. Come experience the industry's most sophisticated enterprise cloud management solution today. Abiquo.com.
Okay, so that tells you what we do, but today we're focusing not so much on our product, but on a general issue that we think is pretty significant. And we're going to make a fairly bold statement to start with, a fairly controversial statement. Today, virtualization is not the enabler of the cloud, it's the inhibitor, which sounds like a pretty radical thing to say, but let's see what I mean. Here's a quote from Gartner. Operationally, virtualization appears to be a wash at best. It actually creates additional costs on a worst-case basis. That's a pretty strong statement. If you're like many data centers, only 25 to 35% of your capacity is actually storing real data, and we know the statistics for server utilization too. We see them here. So this is the result. If we talk about server utilization, we were at 10%, and virtualization has allowed us to get to nearly 30%. Now, in some ways, that's a pretty big increase. We've trebled utilization, but it is nowhere near the ideal value we need. It's not even half of the ideal value we need. So virtualization is not delivering its promise today. Same is true of storage. Again, we've managed to increase the storage utilization a little, but it's still halfway from where we need to be. And those are really significant figures because unless you start to get those numbers up, virtualization does not deliver on its promise. And here's why. Even with virtualization, we tend to over-provision, and it's difficult to drive utilization above 50%. So half our capacity isn't being used. We're not going to make the savings and fulfill the promise unless we can do something about that. Different issue today, here. Lack of governance is the number one reason why cloud implementations fail today. This is Dave Linthicum, who's a pretty respected analyst in this area. That's, again, a pretty big statement. So what's the problem? Easy. Humans. That's what the problem is. Okay, and I'd like to show you some reasons why that is and why we can do something about it. Go back to this spaceship diagram. This is our view of the future, and I'll explain it to you a little here. In this outside ring here, we have the physical infrastructure. This is the servers and the storage and the networking. And that may come from your local data center. It may come from other data centers that you own around the world. You may buy resource in from a hosting provider or even an IaaS provider like an Amazon or a Microsoft Azure. And those are all contributing compute and server and networking resources, physical resources, into this notional thing we call the resource cloud. And it's the responsibility of the IT infrastructure team to ensure that those resources are delivered at the required service levels and all that kind of stuff. But we completely separate the physical infrastructure from the consumption of those resources. And those resources are consumed by the guys in this inner ring here, the virtual enterprises. And we talked a lot about virtual enterprises yesterday and gave you a lot of detail on that. I won't go through that in too much more detail. But the virtual enterprises are the consumers of that resource. Also in this diagram, we've got the libraries at the top where we can allow those enterprises to maintain their own private libraries of virtual machine images. So, for example, snapshot images that you may have taken of your running servers. Or we might allow you in the shared library, we might allow your IT organization to define a set of predefined virtual machine images. So, for example, here's our standard Windows 2008 server. It's got the corporate antivirus that we require on it. It's got all of those other pieces of management software on. That's our standard Windows 2008 image. Use it out of the library, drag and drop it, and off you go. But the real critical point in this vision, which is where we believe the future is going, and the key here is the separation between the physical world and the virtual world. Remember, today, that separation is not clean. Today, the IT infrastructure team is still provisioning all servers, be they physical or virtual, and that's a bottleneck and a problem. Now, that's not the subject of today's discussion. Today's discussion is about this part, what we call the defining moment. It is the mapping between the virtual world and the physical world. And what I want to suggest to you today is that this part of the process is much more significant than people have realized so far and has some serious shortcomings that we need to overcome. It is the cause of all of those issues that we looked at earlier. So let's imagine what happens here. We provision a server, we provision storage, whatever it is, in the virtual world, but somewhere out in the physical world that has to end up existing. And the business policy that we keep talking about is how to decide where in the physical world that virtual asset should be. And when you do that, you have to ask yourself a bunch of questions. And the most basic questions is, will it run and will it fit? In other words, if we talk about a virtual machine image, we have to find a physical machine out there that has the right hypervisor, that has enough resources left over to run it. This is really basic stuff. Your system doesn't work without this. So that's pretty critical. For the next piece, start asking yourself questions like, does the machine you've got a bunch of candidate machines that satisfy the right hypervisor, they've got enough resources, but do they have the required functionality? Not all servers are equal. Does it have what you need it to have? Is it connected to the right type of storage? All of those sorts of things. Pretty obvious stuff. Do we need to have co-location with other systems that we've got? So do we need to have this set of machines together, located in the same place? Because if we take an application that consists of 10 servers and we put them in different data centers, that likely doesn't work. They may well need to be co-located. But the opposite of that is also true. If you're trying to build resilience into your application, you actually want to say, no, I do not want it co-located with these ones. The whole point of this is it's got to be in a separate physical data center. Are those issues being taken into account? This is pretty easy stuff, but it's essential to consider. And remember, it all comes back to that defining moment where you have to decide. Now we start to get a little bit harder. Was that hardware bought for another purpose? We've got physical infrastructure there that's been placed, but we may have bought those servers for a particular task, and we want to make sure they're only used for that task. So there's another question you have to add in. Will it be secure enough? Are we asking the right questions based on the application that we have or the enterprise that we're talking about? Is it safe to put it on that server? So, for example, if we say, this is our core trading application, we want to make sure that only runs in our data centers. Can we do that? That's obviously a critical item. Is there something incompatible already there? Now, this starts to get really hairy stuff. Can I go and look on that physical server that's a candidate for where I want to put my application and make sure there's nothing else already there that might be nothing to do with me? Take the classic Wall Street example, the research and investment banking. Am I sure if I'm going to deploy a research application that there isn't already an investment banking application on that machine? Because if I don't, I'm breaching compliance. Same goes for storage. Am I making sure that, I provision a piece of storage? Am I making sure that there isn't already some storage there, some data there that belongs to a completely different enterprise with which I am not allowed to share physical hardware? How are we going to deal with that? And then we start to get to the really, really difficult stuff. Are we getting low on resources? Do we need to save costs? Now, just think about that question for a moment. That's a really difficult thing to answer. If I have 1,000 servers in my environment, how am I going to make sure that I'm putting this virtual machine image in the place that is going to give me the best utilization? Difficult question. And if we start to work on the cost-saving thing, let's imagine that we, as an organization, as everybody does from time to time, we get to a situation where we need to save cost, but at the same time, we're running out of resources. How are we going to deal with that? These are hard questions to answer. No human could reasonably consider all of these issues every single time a resource is provisioned or moved. So, getting back to the jokey video at the beginning, that guy has to make sure every time a machine is provisioned that it's put in the most efficient place and consider all of those other things. And this is a really big deal because it is the key to making the cloud work for you, and without it, it won't. But all existing solutions expect humans to do this. And that's why they don't work. That's why the virtualization doesn't deliver the savings it was meant to, why all of those statements at the beginning can be justified. And our solution to this problem is what we call business policy, applied automatically and consistency every time. So you don't let humans do it. Humans decide what the policy is, and technology implements it. That's the answer. So let me give you some practical examples. We're really big on practical examples. We don't just like to sort of talk technology. We actually like to show you what we mean and what it could actually mean for your organization. And we're going to show you a bunch of different classes of policies. And this is not necessarily an exclusive list. There are bunches of other things you could do as well. I'm just going to show you a few examples of what I mean. What I'm really trying to get over here is to have you understand that defining moment is really critical, and that's really what we're trying to bring forward today. Let's consider performance. You have no idea how long it took to make this PowerPoint slide. We could optimize our utilization for performance. Okay? So what we're doing there's our rack of servers, and as each virtual machine gets deployed, we're saying, spread it out across the physical hardware you've got. Now, this is not a very realistic scenario because there are only very limited circumstances in which you could do this. But if your objective is to maximize the performance of all your applications, irrespective of the cost, and in some certain defined circumstances that might be what you want to do, that's what you want to do, is to spread that load. And you can see, using our product, that's how you define it. I've said there for my New York data center, I want to set a load balancing rule that sets it to performance. It's as simple as that. But let's look at the much more usual case, which we call progressive. And here, we want to load our servers up one by one until, so that we're getting the maximum utilization out of each one before we move on to the next. And of course, this is where the real difficulty comes in. If you start with that premise and say, okay, I looked at that first of all, it's not that difficult for a human to start working out those first pieces. But what happens when things start to move around? So in this example, there's a hole appeared there. Those VMs have disappeared. Okay? Now, where am I going to put the next one? I've got to start filling up the gaps, and this is where the problem becomes complicated. I'm showing a very simple version of it here. Imagine you've got 1,000 servers and 50,000 VMs running. Now you see the scale of the problem. And the natural thing that humans will do is make sure there's a good amount of room. It's what the statement at the top from CloudBuzz says. Humans tend to over allocate. Okay? So you want that to happen. You want, when another VM comes along, you want to find the most efficient place to put it, which may be different to the answer you would have got 5 minutes ago, or even 5 seconds ago. You've got to make sure that you're putting it absolutely in the most efficient place, because this is the only way that you are going to achieve that utilization. You're never going to achieve it by a human going, we'll put it there. And then we get some other things we can do. If we're in a progressive mode, we can start to say, well, we're only going to turn on the machines as we need them. We've got that infrastructure there. We've got that capacity when we need it. But we're going to have the solution automatically decide and automatically determine when those new servers are to be turned on. And think of the implications of the saving of power and cooling and all that kind of stuff by doing that. So, reducing hardware costs because we're increasing utilization, truly increasing utilization, and power and cooling all reduce. And now you can really start to get some of those savings that the cloud has promised, the virtualization promised, and hasn't yet delivered. Now let's just look at another variation on that same theme. Imagine that we're getting to the stage here where we're starting to run out of resources. And I've deliberately shown you just one rack. Of course, this will go across your entire data center. But if you actually work the math out, that rack is now at 93% capacity based on the rules that we've set. And the rules that we've set here say we're going to take the ideal. There's fairly common ground that says it's most ideal to run your servers at about 70% capacity. That's the ideal we want to get to. So at 70% capacity, we've only got, 5 or 6 little spaces left at the top. We're going to run out of space here. But simply by changing the business policy to say, move that to 80%, and you can see, again, in our software how it's done here. So set the load level for the New York data center, rack number 1, all servers, I want you to increase the CPU to 80% from 70%. Okay, one change to the policy rule and see what happens. It starts filling up the gaps. Okay? So that is a way of using business policy to say we don't necessarily need to go out and buy more resource if times are tight. We could just increase our utilization to cover that. Now, if you try to do that with a traditional system, it's absolutely impossible. But you can see here, we've shown you in this graphical way, that it's actually relatively straightforward to do it if you've got the third leg of the tree, which is business policy. And you can also do things like balance your hardware. Clearly, you have in your data centers typically a mixture of new and older, moving towards legacy hardware. The problem with that stuff is that they perform at different speeds. So when you talk about, I want a CPU core or 10 CPU cores for my virtual machine, what kind of CPU cores are we talking about? So you can use this to actually balance your hardware needs by saying, for example, that server, I want you to set its utilization to a lower figure. And the sort of simple analogy I'm making here is, the server on the right is bigger and faster than the older server on the left. So if I just say I want you to only give that one 35% utilization in crude terms, I'm allowing it to match the big guy. There's another way to do that too, and that is in our again in our application, but this isn't exclusive to us. You could do this anywhere. You could tell the system that the parameters of that physical machine, which in our application we would normally auto-discover, you can actually adjust them, so you could actually tell it that it has less CPU than it really does. It's effectively another business policy that you're putting there. So you actually tell the system, this only has 2 CPUs when it really has 4, and that way you will be effectively halving the utilization on it, so to get more out of that server. Let's just talk a little bit about the virtual enterprises. I went into this in a lot of detail yesterday, but we just need to know a little bit for talking about business policy. This is our trading operations virtual enterprise. And in that virtual enterprise, we have a set of users. And the users are think of the virtual enterprise as being the application side of the house. So, this is our trading operations system. We have a set of IT people whose job it is to maintain those systems. They're not the people who provision the infrastructure, but they're the people who maintain the application. And add into that a series of virtual data centers. And those virtual data centers contain networking resource and server resource and storage resource. And the key to the virtual enterprise is that it is completely autonomous. It can do, those people can do whatever they need. They can configure that thing however they want. It's just like having your own physical data center, or in fact multiple physical data centers. And you can, you rewire the networking, all that kind of stuff, however you want. But you are operating within the parameters that have been set for you by the IT infrastructure team here, for example. So here it's telling us these are the limits, the resource limits, which our enterprise is allowed to consume. It's another example of a different kind of policy, but policies on what you're actually allowed to use. Another example here of policy being applied for our particular virtual enterprise to say what that virtual enterprise is and is not allowed to use. So our trading enterprise in the US, so I think this is our investment banking one. You can just see it in dim over there. Our US investment banking operation is only allowed to use these particular data centers. It's not allowed to use those ones which are outside the US, for example. Another example of policy here, reservation. This is saying I want to reserve particular hardware so that it is only usable by a particular enterprise. And you can get more granular than that if you want to. But here we're saying, for example, we're going to take our data center in Boston, our physical data center, we're going to take this particular rack, and we've reserved a set of servers that are only going to be used by this virtual enterprise over here. That's reservation. And now more business rules here. We've got the load balancing we talked about here. This top half of the screen here talks about rules that will apply globally. So we've set a global load balancing statement that says we're going to do that progressively, so we load each machine up fully before we move to the next one. But in fact, we've made an exception down here for the New York data center. We've said that one we want to run with performance. We've also set a couple of other rules here. We want to restrict server sharing. So we've got a global rule that says the enterprise Japan, or we'll do the one above, the enterprise US investment banking must not share any servers with the enterprise US research analysts, thereby making sure that a physical machine can never have applications from both of those running at the same time. And we're showing you in terms of physical service here, you can also restrict that in terms of a rack or in terms of an entire data center if you want to. So you could just say, okay, based on how we know our network topology is, you can't place them in the same rack or the same server as you've got here, or even in the same data center if that's what you want to do. And here's an example of just adding that exact rule that we've got there. Restrict shared server, US investment banking, and US research analysis. So we've got really three key parts to this puzzle. We've got the infrastructure part, which is what everybody talks about in cloud. The infrastructure part, the physical infrastructure, are using cloud to reduce the amount of physical infrastructure we have, to use it more efficiently, and all those sorts of things. So that's the big money saver. And we clearly get benefits, as we talked about yesterday, using the virtual enterprise. We get distinct benefits to the application side of the house. They can deploy their own and completely control their own virtual enterprise as if they had hardware in-house. They just don't have to maintain the hardware. Give them full flexibility, give them full autonomy, and that makes them much more agile. As we talked about yesterday, you can deploy machines in seconds instead of having to have IT deploy them for you. The infrastructure team in days or even weeks in some cases. You've taken that task away from the IT infrastructure team. But we are suggesting that the third piece of the puzzle here, which resolves the remaining issues, all of the ones we talked about before, really getting those utilization figures that we need to really justify those cost savings, that want to really get those cost savings, and to make sure that the system is operating in accordance with all of the governance and security and compliance and all of that kind of stuff that we've gone through. The business policy is the absolute key to that. Just lastly here, one more statement. This is a very recent statement by Forrester. And this is a survey that we commissioned from Forrester, but I think most people would agree that Forrester is pretty independent. It doesn't write what the vendor wants it to write. This is a report that we just commissioned from Forrester that we just released yesterday. But without automation, there is no such thing as cloud. Smarter automation will catapult cloud computing concepts through today's hyperbole into a reality that will alter business flexibility. That's a pretty strong statement from Forrester. And obviously we're very pleased with that outcome. Please go and get the report for yourselves. You can get it directly at abiquo.com/Forrester. And take a look at that, and we think that'll help you understand the significance of business policy and how it is the key to truly enabling the cloud. Thank you very much.
Thank you, Pete.